Hello everyone, welcome back to the second video of cryptography and network security. Now I've decided to make videos based on each topic individually. So instead of making lengthy videos, I'll be making videos on one topic. So we had completed the first chapter, that is chapter 1.8 from the content, and now we'll move to the chapter 3.1 as per syllabus. So in 3.1 we'll have to study about symmetric encryption and what are the types of algorithms in encryption and decryption algorithm used in symmetric encryption. So first we'll be as you can see in the image, we have the model of symmetric encryption, simplified model of symmetric encryption. So basically what happens in symmetric encryption? So we have to remember 5 ingredients. So as you can see, I have drew all the 5 ingredients. So first we have a plain text. I'll just write as 1 here. This will be 2. The key we have, this is also a ingredient. We'll say this as 3. The ciphertext is y, right? Y is nothing but the cipher, that is we'll say as 4. And last decryption algorithm 5. Plain text is again the same, input and output, so doesn't really change much. So first we will talk about what is a plain text. Plain text is nothing but the original message which we want to send to the receiver. Okay, so first when you talk about symmetric encryption, what do we describe it as? So same thing we have to tell again, that if you have to transfer a message or transmit a message to a friend securely, how will you do it? You have to do in such a way that it's secured, logged, encrypted. And for that we are using, like for example, lock and key type example I can give you, where the lock is put by you. You have a key, you might have an extra key, so you give that key to your friend. So here the key are same, right? Both the key, though it's originally 2 keys, but still it's the same. So here it's symmetric, the same way how you logged the lock, the same way you're unlocking it. That is nothing but symmetric. If you talk about asymmetric, asymmetric is nothing but the locking and unlocking methods are different. Understood? It's not a good example, but still let me give an example. You have locked it, and the someone else used this different key and unlocked it. And suppose if it is a lock, people how they used to, what is that, spawners, and then just do like this and they break the lock. That is nothing but a third party people or crypt analyst who is trying to hack into the information channel and change your message. Okay, so let's not get distracted. The plain text, you understood the concept of symmetric encryption, right? Both the sides, sender side and receiver side, they use the same key. It's just like symmetric. What's happening, the like two hands, if you keep like this, or if you keep like this, how this is exactly symmetric, right? Even human body is also a symmetric if you cut exactly from the center. So here we have the plain text is nothing but the original message you want to send. This plain text can be numbers, some words, sentences, images, videos, anything like that. And they are intelligible in the sense, what is the meaning of intelligible? That it's very easy to understand and very easy to read. You can understand. Say input. It is the input to the encryption algorithm. Okay, we'll move to the encryption algorithm. Encryption algorithm is nothing but a mathematical function or a process that transforms the original message, that is plain text, into a ciphertext. Okay, now as soon as we already knew that plain text is the input, so we'll say plain text is transformed into ciphertext. Okay, then it takes the plain text as input and generates a ciphertext using the process. What is the process? It does undergo substitution. What is substitution? Nothing but replacing the letters. Suppose you had to send a message hello. The hello will be substituted by K, H, L, L, E, like something like that. So this is substitution. Okay. Substitution. Then transformation. What is transformation? That is rearranging the words. Now first, one good example is if you see to the beginning 1, 2, 3, 4. Here A, B, C, D. Okay, so I have to go to the last 26, 25, 24 and 23. So this can be converted into like this. and the numbers are 26 to 25, 24 and 23. So this is nothing but substitution. Okay. Then we have to do transformation. What is transformation? This ZWXY, I'll do YZWX. Okay. So this is nothing but substitution and transformation. How it is done? It is done using a secret key. Okay. Without this key, this substitution won't be happening. And since we are using, okay, so one more thing over here. Okay, we will talk that about in the secret key part. We understood, right? Substitution. This is the substitution part which I have written here, and this is the transformation part. Okay. Then what else happens? It makes the plain text unreadable. See, it makes the plain text unreadable. Since it is converted into ciphertext, now it's unreadable. Next, we'll move to the key. Secret key is nothing but the actual secret key which helps in transformation of the plain text. Now this secret key is independent of plain text and algorithm. In the sense what? Suppose there is a secret key, let us say master. Okay. So if master, the word master is a secret key, this secret key can be used on any plain text, for every plain text. So it is independent of plain. It's not fixed that one plain text should have particular key. It's independent of all the plain text, and then it is independent of algorithm. Any algorithm can use this secret key as a input, like master as a input of secret key. Okay, and determines the transformation. This secret key determines the transformation. In the sense what? Same plain text, same algorithm, but each key, like different key generates different outcomes. See, if I used one key, I would have got this kind of substitution. In some key, instead of WXYZ, it will take the previous letters like S, PQRST like that, or sometimes UVWX like that. So that depends on secret key. Okay, determines the transformation. In the sense what? Different key can generate different transformation. Then we have the ciphertext, that is Y. Y is equal to the transmitted ciphertext. Ciphertext is nothing but the unreadable message which has been transformed. Now what are the properties? Unintelligible. In the sense what? It's not easy to understand. It's not understandable itself. You cannot understand it. It's very difficult to read also. Sometimes not just understanding, but it's very difficult to read because it's all jumbled words. Like suppose if I give you a word like XQ#13A, can you read this? Can you understand this? No, you cannot. So it's just like that. Depends on both plain text and secret key. In the sense what? Since the ciphertext is nothing but a combination of transformation substitution from plain text and secret key, that's what it says. It depends on the plain text and on the secret key. Then only this ciphertext is generated. Then it sees as random data, appears as random data. So you cannot say the exact order of. See now, as you can see here, have I repeated in any order? Like I have given everything randomly. XQ, then some secret character, then letters, numbers, and then a letter like that. Then it is safe to transmit over insecure channel. Since it is unreadable, ununderstandable, now we can transfer this in an insecure channel. Now coming to the decryption algorithm, this is the last ingredient. It is also a mathematical function which also does the same thing as the encryption does, but in the reverse way. Okay. Now what are we giving as input here? Here Y is the input. What is Y? Y is nothing but a ciphertext. Ciphertext is the input over here. Same process, same key is used. Instead of plain text, we are using the ciphertext. We are doing the reverse step over here. Okay, so here the mechanism may be different. How we are doing here, encryption and reverse process might be different. We will be looking that in different algorithms, how the reverse algorithm differs or varies. We use the inverse of the key, inverse matrix over there. We will be seeing that in the later videos. It uses the same secret key and gives the original message, plain text. But see here, this is the original. Plain text is equal to decryption algorithm with key and the ciphertext. Okay, so this completes the basic simplified model of symmetric encryption. If they ask you what is symmetric encryption, you have to explain with this diagram. And for the example, I have given AES. We have further 4 topics under the same 3.1 chapter, that is Caesar cipher, Hill cipher, etc. So that also can be given as the example here. Advanced encryption standard. This is one of the modern encryption methods used. you can simply give here. So whatever I have explained over here, you can easily elaborate and write it with qualitative words and gain full marks for this. So we'll see in the next video. And also don't forget to like and subscribe and comment what else is missed and what else you want me to explain. I'll be covering all the topics from this module.